Hi, everybody. This is Kubernetes SIG architecture meeting for January 9th, 2025. Happy New Year. First meeting of the new year. And we just have one item. Sergey, take it away.
I was muted. Okay. Welcome, everybody. Happy New Year. As John said, I'm the only item on agenda, and this item is from past release. We already discussed it on mail thread to some extent, but now it's a codified document that we want to start moving, like approving first, and then moving further into like some kind of policies that we can follow. This document is about feature development and how it relates to changes in container runtime required to enable those features. So this document was originally a little bit more generic. Now it's very specific since we only actively engaged with containerd and CRI-O. So we made it very explicit for containerd and CRI-O. So before I go into specific policies, is there any document on what it is about? Okay. So as I said,
Sergey,
yeah.
let me just ask one question. So just sort of from a SIG architecture perspective, right? We probably want to think about precedents and implications, right? Here we're talking about kind of a lower level, we have an API, we can express certain things, and then we have we have multiple implementations of that API. Like gateway is very similar, right? Like, so what do we want? I guess just to put it in the people's minds, probably thinking about this in the context of like, what do we think generally our policies and principles should be around those type of topics. So I'll just put that context out there.
Okay, yeah, it's actually a very good context. There are some example of it, like as you said, gateway API, something like that. It's different though because in case of those APIs, you upstream or like vendors or whoever implements them, they implement some like full API to the extent of like the ability. In this case, there is a two layers. Like one layer is a Kubernetes feature that is end-to-end feature, including like pod API, like how it interacts with kubelet and what logic lives in kubelet. And then finally, small piece of it is going to runtime. I don't know what other examples of that in Kubernetes. Maybe to the extent CNI, but not that much. I don't know. We don't have that many pluggable things in Kubernetes. But yeah, one important note here that difference of container runtimes and Kubernetes features that container runtimes don't implement the whole feature. They implement APIs needed to enable parts of this feature. And often a lot of logic lives in kubelet itself as well. Yeah, another note is that containerd and CRI-O today doesn't have notion of feature gates. Containerd started doing experimental features, which is kind of similar to what we have with alpha feature gate, but they don't formalize it too much. Like it's still just like experimental feature, something typically big and typically on a level of alpha and not recommended for production. So there is no really a notion of beta APIs in neither containerd or CRI-O. So if it's shipped, it's shipped. Like it's already stable in GA and people can use it. That's why, like originally, I started putting some policies with the notion of like container runtime implementing some beta API, but like there is no beta APIs in container runtime. It's either shipped or not shipped. Also, yeah, since I'm talking about versions, I also wanted to highlight that one of the reasons we started this conversation is because of Containerd 2.0 problem. Containerd 2.0 has a history. They started release and like starting teasing about the release of Containerd 2.0 more than a year ago, and it went through some delays, and ultimately it was delayed more than a year since it was planned originally. So for more than a year, we've been expecting Containerd 2.0 release coming very soon, like in a month or so, and it was always in a month or so. And then every new feature that we developed was for in Containerd 2.0 branch, meaning that users cannot really use this branch because nobody in Containerd community has very little usability and like adoption for non-stable releases. Like everybody using Containerd typically using stable releases, something marked as GA. So we had like at least 3 big features that really depend on 2.0 right now, and we still, even though 2.0 is already released, we still in this limbo because adoption of 2.0 is also a big deal because there are breaking changes. Anyway, yeah, that's just a note. And originally the document was written in such a way that 2.0 would been considered as an okay implementation, but after conversations with Containerd community, it's not really the case. So we removed this language. Anyway, this is about container runtimes and versioning. Now, what's important from SIG architecture, I will go through all the topics, but what's important from SIG architecture perspective and where I'm looking for feedback is how to, I mean, ultimately, we want to make sure that the user experience is great and user workload is portable. They know what to expect from APIs and how APIs will behave independently from which container runtimes they use. And if there is a different behavior, then it's easily discoverable what behavior will be based on some parameters exposed through Kubernetes API. So they don't need to ask for vendor, like, what will happen if I'll use this Kubernetes API? It shouldn't be the case. So last item will be about feature portability, and I will get to that, and it will be a good gateway into questions and suggestions. But if you have questions and suggestions along the way for other items, please also stop me and we will discuss. Okay, any questions so far? Yeah, I see more people joined. Welcome. It's about container runtime and Kubernetes. So first, very uncontroversial, I think. It's about maturity levels. We already had a policy written for deprecation. At some point, we wanted to deprecate features, and we at some point, recommendation to use some other feature in lieu of deprecated feature, but that other feature was still in alpha, or like it wasn't shipped yet. So we don't want this to happen. Like we want, if we deprecate some GA feature or deprecating beta feature, we want to replace it with either beta feature or GA feature. So it should be the same thing. Same maturity level. I mean, we extended now for development of new features. So if you want to ship GA feature gate in Kubernetes, there should be GA build of Containerd and the CRI-O. And we require both to have implementation completed. For beta, since neither Containerd or CRI-O has a notion of beta, we do say that they still need to have stable release. Just like if at any point CRI-O or Containerd will decide to have feature like beta features, then we can talk about it. But right now there is no such thing. So to ship beta of feature of container of Kubernetes, you need to have a stable build of Containerd or CRI-O and CRI-O, and both they should be implemented.
Okay, so let me just make sure that's clear. We're saying we cannot go to beta in Kubernetes unless both CRI-O and Containerd implement a GA feature, the GA features we need to support that beta for both.
Yes.
Okay.
For alpha, again, there is no maturity levels in container runtime. And alpha is kind of complicated because you're merging a lot of pieces all together. So you need to merge CRI API, you need to merge end-to-end tests, and you need to merge some container runtime changes to test those things. So we have a capability in end-to-end infrastructure to test against main branches of container runtimes for Containerd for sure. For CRI-O, I believe so. So the suggestion is to have same maturity level for alpha feature gates. We will require default branch of container runtime, at least one. We don't require both, to have implementation ready and merged, so we can merge end-to-end test alongside with the implementation. So there's a requirement for alpha for same maturity level. Okay, no questions. Then
I think like for alpha, I think there's some discussion in the threads, right? So I think what we want to ensure is that maintainers from both the communities have gone and like there's a and said, okay, we are committed to implementing this. It shouldn't be the case that only one of the runtimes is committed to implementing that. We cannot require a real implementation. All we need is like, okay, the CRI API is looking good from both the communities, and there's uh, agreement to implement it.
I will get to it in this
Okay,
current
all right, okay.
stage. So I split these two into separate policies, mostly because it's easier to explain separately. Otherwise, like one policy will be covering too many aspects. But yeah, that's an important point, Ronald. Thank you.
But just to be clear, we're only taking a hard dependency like this on cryo and containerd, not on other runtimes. We're saying if these two are willing to implement it, we don't care about anybody else. I just want to make sure we're not, obviously tying our hands too tightly.
I think
Yes.
what came up was like a CRI Docker implementation is also as involved and keeping up with new Kubernetes features, they can get themselves into the mix here. So initially, the language didn't call out both the implementations, and based on feedback, are given by okay, these are the only two implementations that are actually implementing everything right now.
Okay.
Yeah, and it's not only whether they implemented uh, and keeping up to date, but also how engaged they are with the community. We really need people like humans participating in conversations, humans that you can ping and ask questions. Otherwise, it's really hard to depend on somebody who is not actually participating. Um, and yeah, but Ronald, to your point, this this item suggests that we have a PR merged for container runtime. Otherwise, we cannot have end-to-end tests. So this is actually have requirement for container runtime.
So I think the challenge here will be like getting in a CRI change merged and the container implementation to one of the main branches, and then going back to Kubernetes and having an E2E test. So I think that may be feasible for smaller things, but depending on how complicated the feature is, it's possible that we just nang the CRI API and then we don't actually finish all the steps up to E2E test. And it may span beyond the single release. So that may be a challenge.
Okay, so yeah, if you can comment on that, it'll be great. So you're saying
Yeah.
that this is not possible, not always possible. Maybe we can relax the language a little bit, but I really don't want to be in a situation when we implemented everything in alpha and like theoretically it's all possible to implement in container runtimes, but when it comes to implementing it, there is so many problems.
Yeah, I think maybe we can call out the three explicit steps here, that adding CRI API, the implementation, updating the runtime, and adding the E2E test. Okay, I'll add a comment.
Yeah, we can discuss mechanics, but I think in principle we should be striving for having runtime and Kubernetes to merge at the same time. Okay. Yeah, minimal number implementations. I didn't mention that. I think this same maturity level didn't talk about number of implementations. Um, uh, I'll need to review it. Maybe it was an artifact from the past. So we require 2 implementations for GA. Save Kubernetes defaults. This is interesting. This is talking about beta and enabled by default features of Kubernetes. So we're saying that if feature is enabled by default as a beta in Kubernetes, then we need to have both implementations already in GA, like containerd and cryo. The reason for that is if we have beta in Kubernetes enabled by default and only one runtime supports it, then customers can be confused and like adopters will need to disable features explicitly if they use different container runtime, which is not a good experience for anybody. Like one documentation will say it's enabled by default, but then like implementations on vendors will have it disabled. So we want to avoid this miscommunication and problems in comprehending. So we're saying like it's beta, but it can be disabled. But if only one runtime supports it, we cannot enable it by default.
I thought we already said that we can't even go to beta unless both of them have it GA'd in a previous paragraph.
I think one of the enhancements
No, yeah.
we went against this, right? Like we didn't, like I think for OCI volume source, we didn't go down this path. So maybe there's further debate to be had for that particular option.
Yeah, I mean, I don't have a strong opinion. To me, it makes sense to be able to go beta not by default, but I saw something Tim was like, well, what's the point? All Claire was like, well, what's the point? So I don't know. I don't have a strong opinion, but I'm just saying, just pedantically, I think it sounded like there was an inconsistency in the document.
No, I think it's not that. It's like, so same maturity level. I wrote it with like one implementation in mind, and then minimal number of implementations just for GA. Like for GA, we require both to have already implemented. Okay, Antonio?
Yeah, there is a difference in betas disabled by default versus alphas, because you think that in beta, don't think in isolation. Think when this gets into the CI and things start to be enabled. So if you are confident and this is enabled with the other beta things, you get some signal. If not that, it's a super signal and we have a super CI, but I can say that having beta gives more signal than alpha, at least in the CI job that we have today.
That's reasonable. Yeah.
That's true, even if it's disabled by default.
Yeah, because there are, I mean, we don't have many jobs and we need to work more on this, but there are more jobs that run things with betas enabling betas than with alphas. Alphas is considered, look, this is, you are rolling a dice. Well, it's not that bad, but that's the thing. So if you are in beta, you have more chances of getting tested.
But it still needs a new CI job that explicitly enables that feature, right?
We have CI jobs that enable all betas, all alphas, all betas, and all alphas. What I'm trying to say is when you are running with the signal of all alphas, you are running in a pretty unstable environment. You are running in a job with all betas at the same time. You are kind of having a better environment.
So we would still need to make sure that beta environment, that all beta environment has the CRI implementation that supports the feature, right?
But that's the point of this discussion, right? Is the problem is with your runtimes, the runtimes are implementing features and Kubernetes is moving at different time, right? So, and I commented there is, I don't think that the runtime have be behind Kubernetes. It has to be the other way around because you need to focus on the feature as a whole, and the feature as a whole is what the user does when do QCTR, apply, pod, volume, whatever. If they do that apply and it doesn't work, well, that's not even better.
But sorry, maybe I'm misunderstanding something here.
Yeah, I think that
I thought we were saying that for beta, only one runtime had to enable it or support it. And you could do a beta off by default if only one runtime supports it. But that would require that, I mean, suppose there's two different off by default betas. One is only supported by containerd and one is only supported by cryo. Then that wouldn't work with the all betas CI job unless they gracefully handle it not being supported, in which case let's just gracefully handle it not being supported and make it an on by default beta.
So then you are right. It's maybe it's not enough for being better. I don't know. This is a discussion. Now that you're making this point, I think that's something interesting, because it means you move this to beta, you need to go through all these jobs and start disabling. And I'm telling you, it's the all beta job is the better thing that we added recently, and I'm not in favor of start doing punch holes for features in that job, because that means we are going to go back to the state that we don't even know what we are testing.
Yeah, I think it's a wider discussion for outside of this thing, outside of this communication, mostly because alphas are not generally used widely for adoption testing. Like people want to have at least beta API to start testing that feature. And if we will change perceptions and it's like stable alpha and like very stable alpha, then we probably can convince people to start testing them. So we use this beta disabled by default to tell customers you can enable it and test it. It's stable enough, but there are some limitations why we don't want to enable it by default yet. If you don't want this stage, then we can have a wider conversation.
One caveat here, because I didn't realize the jobs that test all alphas and all betas, the requirement is that it passes conformance, not the beta test, right?
Yeah.
Of course, that will say. Just to clarify, it's not.
Mhm.
Is that you put something in a cluster that doesn't break the other features.
Exactly. Yeah.
So in that case, it wouldn't matter because you wouldn't be exercising the feature since it wouldn't be GA yet. Conformance test wouldn't exercise the feature.
Depends on the feature, right? If it's a feature like volume whatever thing, of course it doesn't. But it's a feature like evented PLEG, you know. That's the problem with the runtimes is that I mean, if it's volume whatever, yeah, that is clear. If it's evented PLEG or whatever thing, that means the whole cluster gets impacted. So if you can differentiate without that, that's another thing to take into consideration, is what is the impact of the feature in the whole cluster.
Is there any other opinions on betas enabled or disabled by default? Okay, we can try to discuss it in a document, but I would say if you have a notion of beta disabled by default, then I'm okay to allow only one GA container runtime implementation. If you don't have them, then there is no question, like both should have it. If it's enabled by default, I would suggest that we have two runtime implementations. Yeah, Tim?
If we move forward with betas off by default betas, can we agree that you need to have one release of on by default beta before going GA?
Yeah, I think it's generally acceptable, yes.
Not just acceptable, required, right? Like we want it to be the case that there is a release where the functionality is on by default, but still turn offable before we go to a state where it's on by default and not turn offable. Right? So it would be a required stage for us to have.
Yeah, I think this is generally the practice that we follow. And I don't know if this document should cover that, or we need to have a separate document for feature gates.
Okay, as long as we're on the same page there.
Yeah.
Because a lot of times you don't notice something until it actually bites you. And it's really helpful to have it on by default to make it do that.
Yeah, I think this document talks about beta disabled by default because of few caps that we had and feedback that nobody wants to test alpha features as early adopters. And then, like, if you market the beta, then you want to have both implementations already ready. So we get into this like beta disabled by default case. that is acceptable for testing, but still not exposing everybody to this functionality of get-go. So yeah, that's this result of those conversations. And feature gate progression, I think it's separate, and I think it's very well established that you need to enable beta by default first, and then you go to GA.
Yeah, David's got some things he's presented here related to that with feature gates. But I think, of course, David, we have beta APIs off by default. So even if the feature gate's enabled, if the APIs are, and we're not going to turn those on by default ever, right? So it's a little bit wonky, but
We mostly use pod API, so we don't care. Okay, I'm moving on. So on guarantee portability, this is the item that Mrunal was bringing before. Tim, you still have a hand. If you can lower it, it will be easier for me to understand if you have a question. So guarantee portability, Mrunal brought it before. We want to make sure that every feature we develop in Kubernetes is implementable on both container runtimes. That's why we're trying to come up with some language, and maybe it will be language very, very specific to container runtimes. There is a long conversation here in the comment. Ultimately, we want to make sure that we have ACK or approve from maintainers of both container runtimes that this feature is okay to proceed with. And this is before feature even approved as a cap, and even before it's moving to alpha stage. Without that, we can end up having some features that is specific for one runtime, and it will never be allowed to be released. And yeah, we don't want that situation, and we don't want people to spend time on this before they get any approvals. And one note here, I think that it may sound as more bureaucracy and paperwork, but ultimately just, I mean, we have both Containerd and CRI people really engaged into community, so I don't think it will add too much conversations. It's just codifying what's already happening, so it should be fine from bureaucracy perspective. Then guaranteed implementation, we want, yeah, this is talking about this mechanics of we want CRI API to be merged alongside implementation and tests. So we don't want to allow CRI API to be merged first in the hope that it will work fine for Kubernetes, so Kubernetes can be using it, and it will be working fine for container runtime. So we want all the PRs to be end-to-end. Then we can have some mechanics of how we split it up and like how we do like release procedures. But generally, you need to merge all together, and it brings interesting challenge of how to do feature development. And there is some document from a past that I was trying to explain how to do feature development. Oops, not new window, new tab. So this is some mechanics of like how do you get review these changes, and then you need to import some beta tag of CRI API in your container runtime, and then implement it in container runtime, and then you have both of them kind of ready together. And then mechanics of what goes and being merged first, it's a separate one from you have all the PRs ready. And last one is, as I said, that I think most of the feedback I want to get from this group is feature discoverability. This thing is talking about features we implement, and that features needs to be not only implementable in the sense like people implement the feature, like a reaction of some CRI API is like no op. Like we have an API, we react on it, but we don't do anything. We want features to be actually working on both API, both container runtimes, and we don't want to design any features for Kubernetes that is not working on one of the container runtimes in principle. It may not work for, there are some examples like some Windows features is fine, and Windows is easily discoverable through node properties, but we don't want to implement some feature that is only working on one container runtime in principle, and other container runtime don't want ever to implement it. Also, if feature using some kernel properties or some environment properties that are very specific, then those needs to be discoverable for end users through some Node API or Pod API. So Kubernetes API needs to be designed in such a way that customers easily can understand whether the feature is working or not, and it's not dependent on like CRI configurations that is not queryable from Kubernetes API. So you don't want customers to go check with their vendors before they start using the feature. So I try to put it in words here, but and describe the idea in different words. So if you can give feedback on either what I just said or what is written here, it will be great.
I think we added the feature discovery bit, right? In CRI, we can check whether a node has a particular feature enabled, but depends on the kernel. So I'm not sure if you're trying to capture that, but
I intentionally removed it, like Peter added it before. I removed it because I'm not talking about CRI telling which feature it supports. I'm talking about Kubernetes users knowing which Kubernetes API will work and which Kubernetes API will not work for that environment. I intentionally don't want users to go and query CRI to understand what will be working on their Kubernetes cluster.
I think this is something that propagates up the API. I'm curious to hear what David has. David, go ahead.
I just realized I was going to ask a question at a level, one level lower than I think Sergey wanted to talk about it. So I'll let that discussion happen first and then ask my question.
So Sergey, what you're saying is this is not about the kubelet discovering the features that the container runtime supports. This is about the user being able to know that some given feature is going to work based upon that particular node's runtime. Is that the idea?
Yeah, whatever properties we expose through Node API, and I really want to avoid situation when customer need to check the version of a runtime before they use some Kubernetes APIs. They need to, like, ideally it should be something very explicit, saying like Windows. Like it's easy to understand that Windows, it means that it doesn't support, I don't know, like root user override. So that's kind of things.
So are you thinking those would go into the scheduling, like they would use a label selector to say no, avoid these nodes because they don't support this feature, like node feature discovery? Like I'm not clear what the proposed mechanism, I guess, is that you're suggesting, and maybe you're not suggesting a specific one.
I'm not saying exactly what mechanism to use. I'm just saying that it should be exposed in a way very visible for end users through Kubernetes APIs, and user not supposed to go to vendor asking whether the Kubernetes feature will be working or not.
I see.
So Sergey, if I remember correctly, we bubbled up like RRO and user namespace up to the node object when it's discovered by the container runtime. And then like the user can look at the node object and know whether that feature is going to work or not.
I would think
is that what you had in mind? Or
unless it's integrated with scheduling, it's kind of not that useful. So is that done via labels or no?
I think we added some fields to the Node API. I vaguely thought there was some integration with scheduler, but I'll have to just double check it, see what we did.
But ultimately with RRO, what we did is we had this API saying best effort, like try to apply RRO or like definitely apply RRO. So it's and if you said definitely apply RRO and container runtime doesn't support it, it will error out. So we kind of have discoverability through API of pod, saying like I mean, you either have no RRO or you best effort with this transition phase, and eventually everybody will just use force RRO, and this will make it for feature discovery. So you don't have. I mean,
but you don't learn until you schedule and fail.
Yes, but at the same time, like it's not like you supposed to query which features supported or not. You just you either do best effort while transitioning, and then like in a couple of years you just do forced, and it's supposed to be working everywhere.
And that wasn't the case for user namespaces though, right? Though I forget whether we added anything on the scheduling side, but that can be plumbed up easily. Again, like there could be like scale scale issues there. So we'll have to think about that. Yeah.
You get a million different criteria on the scheduler. It's not great. Okay.
Yeah, adding labels for features in transition is not ideal, because if it's in transition, then it will be, stay forever because people already took a dependency on it.
Yeah. Interesting.
Yeah,
well, it's beyond the scope of Node to solve that problem.
Hey, David?
So just to be sure, I understand the boundary on this though. The expectation is that once a feature goes GA, this feature will be present on every current node, and the compatibility problem will only show up for as long as older nodes exist in the cluster. Am I understanding that correctly, or are you trying to forever maintain compatibility with an older CRI that does not support the features required to work with a modern pod API? Like, is this transient, or is this expected permanent state?
So there are two pieces. Like one is like first item is transient. There's a transition stage during which you can expect older CRI still be in use. And in containerd there is LTS branch that is also like maybe like long-term branch that doesn't have new features added. So you're supposed to not fail for this LTS branch unless we drop the support for it in Kubernetes at some point. And second one is about long-term. This is for specific things that like I mentioned Kata containers here, like that something is not supporting this feature in principle, but runtime does support it. But if you configure it in a special way, or you run on environments that doesn't have this support, then it will fail. And the suggestion here to make sure that first users can discover that there is some limitation, and second, it's clearly like behavior is clearly defined, like what will fail and what stage it will fail.
Okay.
I think like David, there's no clear place where we can say that the CRI supports. It depends on the version of the kernel. It depends on other binaries that the runtime may be depending on, like CRIU or so when we, I think, expect all the dependencies to be widely available, that's when we can get rid of such code.
I'm just thinking any sometimes API is extremely difficult for users to rely on. And there's really no dressing that up to make that much better.
Yeah, I mean, example would be if kernel adds some new API that improves the security. Not everyone is going to adopt that kernel. So we'll have to add some plumbing. So if someone tries to use that, we bubble up the error to the user.
I mean,
If
we
they
already
don't have a
have a
kernel that's
parser
enough.
comp, right? So we already have this example. I think Tim mentioned it in one of the comments here. So we already have those different security examples, and we don't have a good way to expose whether those are enabled. So yeah, we already have this problem. I just don't want to design more features like that. I really want to make sure we somehow at least expose this information, not necessarily through labels, but at least somehow discoverability needs to happen. So what I really want to avoid is a situation when it's not like kernel features that some distros don't support. It's more like I don't know, like some vendor specific code that is only available on like specific cloud, and then we have Kubernetes API enabling this feature, and it's only available in single like environment, single cloud environment or whatever. That should not be how we design features, I think. Okay, I don't see any more hands. I would keep this document open for a while. Maybe next week I will start moving it, like end of next week, start moving it into GitHub somewhere.
Okay, awesome. Thank you, Sergey. All right. Any other topics? I think that was the only one on the agenda. Otherwise, let's wrap it up. All right. Thank you all. See you
Bye.
next time.